Good day, class. I welcome you to this class. Today we shall be looking at a fresh topic that is titled Introduction to Statistical Quality Control. Introduction to Statistical Quality Control. Once again, my name is Dr. Chris Isekaibe. I'm a chief lecturer in one of the most prestigious polytechnics in Nigeria, and I'm also a member of the academic board of that polytechnic. I hold a doctorate degree in mathematics and a master's degree in mathematics and a bachelor degree in statistics. I specialize in numerical analysis, statistical analysis, data analysis, and modeling. You can contact me with your research work. If peradventure you are an AI firm across the globe, I will be glad to partner with you to develop advanced mathematical and statistical algorithms or models for artificial intelligence and machine learning. My contacts are +234 80330 21903 +234 7066 297535. My first number is my WhatsApp number, and my email is chrisdavis2015@gmail.com. I'm a member of the Nigerian Mathematical Society, and I'm also a member of the Nigerian Statistical Association. I have quite a number of notable publications, both at national and international levels. I've also presented papers in well-renowned conferences in Nigeria and outside Nigeria. So I'll be looking forward to hearing from you. Permit me to clean the board so that we can go into the business of the day. So I'm looking forward to hearing from you. Take note of my contacts. Masidu, God bless you. So please subscribe to my YouTube channel, Dr. Chris Isekaibe. Click on the notification button so that anytime I upload a new video, you will have the notification. Share my videos on your social media platforms, and as you do, God will bless you. Now, the business of the day. Introduction to Statistical Quality Control. Now, the issue of quality cannot be overemphasized. The issue of quality can never be overemphasized. If a company, a production company, or a service rendering company refuses to maintain the standard of its quality, such a company will definitely run into a loss. Such a company will be losing customers. So quality control has assumed a considerable importance over the world as a result of the wake of globalization of economies. So hence, this has led to increasing competition among business enterprises globally. So when a company fails to maintain the standard of its quality, such a company is heading towards liquidation. So quality control is very, very essential for any organization or firm to survive the highly competitive market. Such a firm should strive very hard to satisfy the consumer's desires. And every consumer wants products that are of high quality. Every consumer requires products of best quality. And of course, you cannot rule out price from quality, because there's a saying that says garbage in, garbage out. When you put in price to get, you put in good money to get best quality raw materials and put them into production, of course, definitely the price of the product will be different from products that are inferior in quality. So the main factor that affects quality is variability in the process of production. It is the variability in the process of production, and when this variability or variabilities are present, then quality is said to be affected. And defects at each stage of production should be monitored, and as a result of that, the quality can be maintained. Every organization, firm, whether you're a product or you're rendering one service or the other, you should try as much as possible to study or to look out for defects at each stage of production or at each stage of service delivery, so as to know whether there is any problem with that particular stage. So talking about quality control is just we talk about quality control has to do quality control has to do with the maintenance of standards in order to satisfy consumers' needs. So every manufacturer, every service provider strive very hard to maintain standards, especially in quality, so as to enable them to satisfy their consumers. And quality, the effect, or there are certain factors that may be responsible for defects in quality or reduction in quality. So such service providers or producers or manufacturers should look out for such factors and see how they can be controlled. Now, let's look at statistical quality control. SQC. When we talk about statistical quality control, what do we mean by that? Statistical quality control simply means the application of appropriate statistical tools to processes to ensure continuous improvement in the quality of products and services, etc. It is the application, this is the application of statistical techniques to maintain or improve the quality of goods through services. So when statistical techniques are applied, it is expected that the qualities or the standard that has been produced by a company should be maintained. The standard in quality should be maintained. So statistical quality control helps to track variation in product and identify their causes. So it helps to track variation. So it helps to track variations. It helps to track variations and study their causes. And study their causes. So when these courses are studied, then of course there will be room for improvement. So systems must be put in place to track variation in products and identify their causes. So statistical quality control identifies parameters that are easy to measure and that are relevant to ascertaining whether quality is being maintained or not. Hence, the use of what we call the control chart. We have what we call the use of the control chart. So this is what gives birth. So statistical quality control makes use of the control chart to study whether a particular production process is in control or out of control. So the control chart is a major tool that is used in statistical quality control. The control chart helps us to know whether a production process or a service delivery process is within control or out of control. They show a step-by-step approach to statistical quality control. They are roadmaps that are helpful in solving problems. So the control charts are roadmaps. They are road maps. They are guides in solving problems that have to do with quality. So they are roadmaps that are helpful in solving problems pertaining to quality. They show warning zones. So these are the things you look at for. There's what we call warning zones. So when the process is about going out of control, that is a control in terms of the quality. That means the quality control chart will give a warning sign. We give a warning sign. So they show the warning zones, the control zones, and the action zones. So these three things are displayed by the control chart. If there is any possibility that the process is about to go out of control, the control chart will give a warning signal. So these three situations can be compared to the traffic light, which signals stop, caution, or go. This warning, this one can mean stop. This one can action sign can say go, and this one can say caution. Take a look at what is going on. So these three zones can be called or compared to the traffic light, which signals stop. There is a warning. You have to stop. The production is about going out of control. And so the major parts of the control chart are quality scale, plotted samples, sample numbers, horizontal lines, and so on and so forth. So the essence of statistical quality control is to develop statistical techniques that will be helpful in maintaining or improving the quality of goods and services. And you know, as a result of globalization, there is a lot of competition among firms all over the world. Every firm wants to win the masses so that they can remain in market. So by doing that, they will monitor the quality of their products. Even some companies go as far as employing what we call the quality control officers. But the quality control officers cannot do the job alone. The best practice is that at each stage there should be proper monitoring. There should be proper monitoring so that if there is any defect, it will be quickly taken care of before the problem gets out of hand. It is not at the finished stage or the finishing stage that the quality control officers should now come and be monitoring or be finding products that have defects. No. Monitoring should be done at each stage, from the stage of getting the raw materials, the stage of buying the equipment, the stage of training workers, and the rest of them. So you have all those things like that. So now an example of the quality control chart is what you have here like this. This is a proper example of the quality control chart. You have it like this. As an example of the quality control chart. This is an example of a control chart. You will have this one, which is called the CL, the central line. From the central line, you have what we call the lower warning limit. Then you have what we call the upper warning limit. Then you have what we call the upper control limit. Then you have what we call the lower control limit. So this is an example of a control chart. When the samples are plotted, if it enters the warning limit, then the signal is being given that the process is about to go out of control. If it enters the warning limit or it goes out of the warning limit, that means there is a signal that the production process will soon go out of control. But if it finally goes out of the upper control limit or the lower control limit, then the production process has gone out of control. But if it goes out of the warning limit, whether the lower warning limit or the upper warning, once it crosses this line up here, there is a warning. Once it crosses this line below, there is a warning. So the production officers can begin to trace where the fault is coming from and fix it so that the process will not go out of control. That is why production quality control should be something that should be done at each stage of production, right from the purchasing of the raw material, the purchase of the equipment, the employment of the staff. The best staff should be employed, best raw materials should be gotten, because there is a saying that says garbage in, garbage out. If you use inferior raw materials, there is no way you can expect the quality of the product to be of high standard. So at each stage of production, there should be a monitoring so that the quality can be maintained. So if it goes below this lower one, this means lower warning limit, this means lower control limit, this is the central line. Then this is the upper warning limit, this is the upper control limit. So if it goes above the upper warning, then there is a warning. So it signals for action. Take steps so that it doesn't cross the upper control limit. If it crosses that means the production process has gone out of control. And if it also crosses below the lower control limit, then the production process has gone out of control. This is as important as anything that we can think of. Now we are going to look at certain subtopics that will help us. Now let's look at benefits of statistical quality control. Benefits of SQC. SQC means statistical quality control. What are the benefits of statistical quality control? The benefits, it helps a very long way because you are dealing with facts. You are not dealing with emotions. So if properly applied, it leads to improvement in quality. One, if techniques are properly applied, it leads to improvement in quality. So at each stage, there will be a monitoring, and once monitoring is done at each stage, then you expect the final stage to have the best quality. Not that you allow the production processes to go from stage 1 to the last stage, then monitoring will now be done at the last stage. Definitely you will see a lot of errors. Then another benefit is that it eliminates the emotion factor. It eliminates the emotion factor. You see, facts are used for analysis. So every factor of emotion is removed. Decisions are based on facts, not opinions. So decisions are based on facts. Decisions are based on facts, not opinions. So because when you are using statistical techniques, of course, definitely you will base your decision on facts. Then number 3 is that workers' quality is enhanced. It enhances workers' quality. Since the workers are involved in the production process and the monitoring process, it enhances their quality, it enhances their performance, it also enhances their experiences. So workers' quality is enhanced. Then another benefit is that it builds team work. So this makes workers, because the whole workers in the organization has one target, or they all have one target, and that target is to ensure that whatever product that comes out of that company will be of high quality. So it enables the workers to work together as a team. So workers' communication is also enhanced. It enables them to work effectively. They work as a team in problem solving. It enables the managers, the supervisors, and the workers to communicate effectively. So it builds teamwork. So those are the 4 benefits of SQL that we have looked at today. Now let us look at limitations of SQL. It also has some limitations. Limitations of statistical quality control. Limitations of SQL. Limitations of SQC, Statistical Quality Control. One major limitation it may have is that it may not be able to solve all problems arising in quality improvement. It is the information given to it. Number 1, when you have data that are not enough, then the SQC may be limited. So data that are not enough may limit the quality of SQC. So when data are not enough or inappropriate or wrongly given and they are used for analysis, it may affect the results. So it may not be able to contribute much in the reduction of variability in complex problems. So when it may not, for complex problems, it may not be able to reduce, it may not be able to reduce complex variations in complex problems. Then number 3, it may be limited if only a part of the organization is studied. It may be limited if only a part of the organization is studied. So like I said from the beginning, when you are carrying out the analysis of quality, or if you want to maintain good quality as a producer or as a service provider, every stage of production must be clearly monitored. If only a part of the process is monitored or the organization is monitored and other parts are left out, then the statistical quality control SQC may be handicapped. It may be limited in delivering the kind of results or quality that you want. So it is good every part of the process is considered, and every variation in every process will be put in place. Then the end product, of course, definitely will be meaningful and will be good enough for all to see. So now let us look at best practices in SQL. Best practices. My opinion is also involved in this subtopic. I call it best practices of XQC. How do we practice statistical quality control effectively to maximize results? There are various steps that must be put into consideration. Number 1, employ the use of high quality raw materials. Number 1, employ the use of high quality raw materials. Not defective raw materials. Now, if you are a manufacturing firm or a production firm, and your aim is to have best quality in whatever you are producing, so that you will have your consumers continually using your product, the number 1 thing you should look out for is high quality raw materials. If you use raw materials that are defective, that are defective, you can never get good. The finished product will also be defective. So raw materials are in various qualities. They are also in various standards. So go for high quality raw materials. That is where it begins from. Your end product may be a bit more expensive than what your contemporaries are having, but consumers will always go for the best quality. Consumers, and you cannot rule out price. You cannot rule out money when it comes to quality. They go together. Price and quality go together. You cannot expect an inferior product to be more expensive than a high quality product. So much has been put in high quality products, so many factors are involved, so the consumers also expect it to be expensive, more expensive than inferior product. So if you are a manufacturer or a producer, you go for defective raw materials, you will soon run out of market. Consumers will begin to detect the defectiveness in your product, and as such they will begin to look for alternatives. So learn to always use high quality raw materials. Then number 2, use high quality and sophisticated equipment. Use high quality so sophisticated equipment. Now, as a manufacturer, you should go for best quality equipment. Equipment that are good to use, not equipment that have been abandoned. There are some companies that go and buy equipment that have been used by other companies, and at various stages, those equipment they break down or they perform below expectation. So ensure that your equipment are of high quality and they are also well maintained and always in good shape. Make sure that ensure that they are always in good shape. Ensure they are well maintained and in good shape. So when your equipment are always in good shape, service them regularly. When it's time for the equipment to be serviced, you service them regularly, and you will be able to get the best performance from them. Then thirdly, employ quality and experienced workers. Employ quality / experienced workers. So workers training / retraining is important. You don't go for workers that are not knowledgeable of what the company does. You look for highly skilled workers, highly experienced workers, and you ensure that your workers go for training and retraining. Ensure your workers go for training and retraining. Unlike in some factories where they will want to use connections to employ workers. Oh, he's my brother, let me employ him. He's my sister, he's my nephew. You are now leaving out people that are highly qualified to handle the job. You are not bringing in family, nepotism, and the rest of them. This is one of the problems that is killing most organizations, even most countries today. They don't give the job to those that are best qualified to handle them. So go for highly skilled workers. Then number 4, at each stage of production, proper monitors should be done. Do monitoring at each stage of production. Before the next production step is taken, you ensure that the first step has been properly checked and errors are reduced drastically. So each stage of production should be properly monitored before moving to the next stage, so that random errors can be checked and reduced. Then step number 5, these are best practices as developed by me, Dr. Chris Isekaibe, as a firm, as an organization. If you employ these 5 practices in your organization, then you will see improvement in the quality. You don't only go and monitor quality when the final product is out. You monitor the quality right from the stage of employing your staff, buying of raw materials, ensure that the best raw materials are bought, check those that are buying it. Some may be compromising. They will take money for the best quality and buy lesser quality. As a manufacturer, you ensure that these things are properly checked. And then step number 5, involve all parts of the organization. Involve all parts of the organization. Involve all parts of the organization in quality management. So avoid concentrating, although some parts should be concentrated more, especially the production part, but every part must be involved. Every part must be involved in the production process, so that you can be able to attain continuous improvement in quality. So learn to involve all parts. Don't neglect any part. That part of the organization you are neglecting may be the cause of the defective you will finally see when the final product comes out. So you try as much as possible to involve all parts of the organization. Now, these are the best practices of statistical quality control. Now, in statistical quality control, we make use of what we call the control chart. Permit me to rub off the board so that we'll now go to type of control charts. So the control chart is what we use to monitor the quality, the production process. We use the control chart to monitor the production process, to study the production process and see if the process is out of control, or if it is within control, or if there is a warning, if there is an action to be taken for it to be in control, and so on and so forth. So now let us look at types of control charts. Types of control charts. Number 1, we have the control chart for attributes. Control chart for attributes. This control chart for attributes is also called the P chart. It's called the P chart. Proportions and percentages are used. Then number 2, we have control chart for number of defects. So control chart for number of defects. And this one is called the C chart. The defects are plotted, then the other one has to do with percentages and proportion. Then the third type of control chart, there are 4 of them, is control chart for sample mean. Control chart for sample mean. And it's called the X bar chart. Then the 4th one is control chart for range. Control chart for range. And this is called the arrow bar chart. It's called the arrow chart. Range means arrow. So the arrow stands for range. So we shall be taking this chart. By the time we take one, of course, we'll know how the others work. It's as simple as ABC. So these are the 4 types of control charts that we use in statistical quality control, SQC. So we are now going to look at the control chart for attributes, the P chart, and see how we can use, we can bring out a sample and how to use it to study quality control in a set of given data from a production firm. Now we are looking at number 1, which is the control chart for attributes. For attributes, it's called the P chart. So we are looking at the control chart for attributes. This P chart is used to control the proportion or percentages. It is used to control proportion to percentages of defectives or of defects in samples. Of defects in samples. Now, it is guided by the assumption that the items are produced by the Bernoulli process. Bernoulli process. Now, of course, when you talk about the Bernoulli process, you talk about having P plus Q is equal to 1. Now, the Bernoulli process takes only 2 categories, and these are only 2 categories. It is either, when you say P, it means that it is accepted, and when you say Q, it is defective. So it takes only, the Bernoulli process takes only 2 assumptions. That is, 1, it is either the sample is accepted fully, that it has no defective, or the sample has defective. So those are the only 2 assumptions. Then the second assumption is that the outcomes occur randomly. Then there is no change in the probability of either outcome for each trial. So it is either it is acceptable or it is defective. So now there are steps involved in using the P chart. The number 1 step is that we are to calculate the average fraction of defective by dividing the number of defective units by the total number of units inspected. Then the second step is that the value of P bar is now used to draw a horizontal line. So P bar will now be the central line. So when we are using the P chart, the central line is known as the P bar. Then we have what we call the upper control limit and the lower. So the upper control limit that is UCL is given as, we now have it as P bar plus 3 square root of P bar Q bar all over N. So that is the value for the upper control limit. Then the lower control limit, the L, the LCL is given as P bar minus 3 multiplied by the square root of P bar Q bar. Let me write it very well. P bar Q bar all over N. So here your P bar plus your Q bar is equal to 1. So your Q bar will be equal to 1 minus your P bar. P bar means the average of the proportion. The proportion can also be given, that is the proportion of defectives or the percentages of defectives. So that is how it is done. So any sample point falling outside the upper control limit and the lower control limit indicates that the process is not in control. So percentage defective is preferred to fraction defective. When you are now plotting this in the control chart, we make use of the percentage defective because the fraction may not be easily plotted. So we take them in percentages and plot them. They will be easily seen and plotted. So this is the formula for the upper control limit for the control chart for attributes. The control chart for attributes is used to control the proportion or percentages of defects in sample proportion. So now it assumes that this particular chart follows the Bernoulli process. The Bernoulli process has 2 trials. So, and it simply means for this particular case, is either the particular sample is accepted or it has defective units in it. So these are the things. So we are going to take a practical example and see how we can use the P chart to solve a real life problem. So permit me to claim this. So we want to take a real life example and see how we can use the P chart to solve a real life problem in statistical, how to study the quality of a particular production process. Now we'll call this example. The table below shows 10 samples shows 10 samples, 10 samples, each containing 200 items, each containing 200 items. The number of defectives are recorded in each sample. The number of defectives are recorded in each sample. Now use the P chart to show if the production process is in control. Use the P chart to show whether the production process is in control. That is the question. So we have the table below. We have sample numbers. Then we have a number of defects. We have number of defects. Okay, let me write it out neatly. Sample number, number of defects, number of defective. Then we have, of course, we'll come again and have fraction of defective. So we are going to rule it this way. So we're going to have it like this. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 samples that we have. Then the number of defects. Then the number of defects are, for the first one is, we can close it like this, so that we can have enough space. So we have, for the first sample, the number of defects is 20. The first sample is 20. The next one is 15. This is 25. 26. 30. 12. 28. 15. 10. And 25. So that's what you have. You have 15, you have 20, 15, 25, 26, 30, 12, 28, 15, 10, and 25. So getting their fraction, you should know that the fraction defective is number of defective over 200. So fraction defective is equal to number of defective all over 200. You know, each sample has 20 items. So for you to get a fraction, you divide each by the number of items in each sample. So the first one will be 20 divided by 200. That will be 0.1. Then the next one is 15 divided by 200, 0.075, 0.075, 0.075. Then the next one, 25 divided by 200 is 0.125. 0.125. Then 26 divided by 200 is 0.13. Then 30 divided by 200 is 0.15. 12 divided by 200 is 0.06. Then 28 divided by 200, 0.14. Then 15 divided by 200 is 0.075. 0.075. Then 10 divided by 200 is 0.05. 0.05. Then 25 divided by 200, 0.125. So these are the fractions that we have. These are the fractions we have. So permit me, I can also put these fractions in percentages, or if I don't feel like, I can say, let me put them in percentages. I can say percentages or fraction. Fractions. These are the fractions. So now 0.1 in percentage times 100 will be 10%. Then 0.075 will be 7.5%. 7.5%. Then 0.125 will be 12.5%. This one will be 13%. This one will be 15%. This one will be 6%. This will be 14%. This will be 7.5%. This will be 5%, and this will be 12.5%. So that is what we have there. That is what we have. So we are now going to calculate the total number of defectives. Total number of defectives. Total, can call it a total number of defectives is 206. So we only need the total of the number of defectives. So the total number of defectives is 206. So now, for us to get our p-bar, permit me to claim the question so that we can get our p-bar, and that the p-bar is the central line, so that we can begin to make progress as we. So our p-bar is equal to total number of defects all over total number of units inspected. Total number of defects all over total number of units inspected. So the total number of defects is 206 all over the total number of units. Remember, we have 10 samples and each sample has 200 items. So the total number of units inspected will now be 200 times 10, that will be 2,000. So it will be 2,000. So now 206 divided by 2,000, you are going to have our p-bar to be equal to 0.103. 0.103, and this is sitting as our central line. So our central line is what you have there, is 0.103. So if you have that as our p-bar, remember our q-bar will be equal to 1 minus p-bar, and that is 1 minus 0.103, and that is 0.897. So our P bar is what you have there. So from there, we can begin to calculate our upper control limit. Our upper control limit, our UCL, will be equal to P bar plus 3 into square root of P bar Q bar all over N. That will be equal to 0.103 plus 3 into square root of, you have 0.103, which is our P bar, then our Q bar 0.897, we cover all over. Then our N is the number of items in each sample, and that is 200. So carrying out this arithmetic, you will have our UCL to be 0.1675, 0.1675, 0.1675. So that's what you have there. Then permit me to use this side to calculate our lower control limit is equal to P bar minus 3 into square root of P bar Q bar all over N, and that will be equal to 0.103 minus 3 into square root of 0.103 into 0.897 all over 200. You carry this and you subtract it from this. This is 0.103. That is our P bar. Then when you carry out that arithmetic, you have 0.0385. 0.0385. So that is our lower control limit, our LCL. So now that we have been able to get the central line, the upper control limit, and the lower control limit, we are now going to plot these in a chart. We are now going to plot it in a chart, in a control chart called the P chart. We have been able to get all the ingredients that are needed for plotting the chart. So permit me to clean part of the board. Take note of the central line, which is our P bar is 0.103. Then the upper control limit is 0.1675. Then the lower control limit is 0.0385. You need to take note of that. So at the end of the day, you will see that we have a lot to do. We really have a lot to do. So permit me to clean this part of the board. The data will also be used. So the control chart is what we are about to draw now. We are about to draw the control chart. The control chart. So please permit me to also clean all these parts so that we know how it goes. So the summary of what we have, our P bar, which is equal to the central line, is equal to 0.103. Our upper control limit is equal to 0.1675. 0.1675. Then our lower control limit is equal to 0.0385. 0.0385. 0.0385. So now permit me to draw the chart. So the number of samples will be here. Number of samples. Number of samples on the x-axis, and of course this will be the percentage of defectives. So the percentage of defectives will be on the y-axis. Remember, we are not using the fraction, we are using the percentage. So now, if we go continue, we are going to have the scale. The highest percentage of defective there is 30%. So we can start from 5, 10, 15, 20, 25, and 30. So the samples are 10. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the first 3 things that we should do here. Now, if you look at the paper, since everything is put in percentage, please take note of this very well. The P bar, which is the central line, if you convert this value to 10%, is going to be somewhere here. 10.3 will be here. So this will be our central line. Then our upper control limit will be, if you convert this to 100%, it will be 16.75. 16.75 is a bit above 15. So you bring it here. This will be our upper control limit. Then our lower control limit, if you convert that to percentage, that will be roughly 3.85%. 3.85% is below 5. So these are percentages of, so you bring this down here like this. You also bring this down. This will now be the lower control limits. So that is what you have. Then now, we'll now begin to plot. The first fraction of defective is 0.1, and 0.1 will give you 10%. So 10%, so under 1, you have exactly 10% is below this line, is here. Then the second one is 0.075 under the second sample. That will also be 7.5%. Of course, we come here again, we put it under 7.5 is between 5 and 10. Then the third one is 0.125, and that will be 12.5%. So 12.5% will be above 10. It will come here 12.5%. Then the fourth one is 0.13, that will be 13%. So 13% will be a little below this. Then the sixth sample is 0.06, and that will be 6%. So 6% is a little above 5. This is 5, a little above 5. It will be here. Then the next one, the seventh sample is 0.14, which is 14%. 14% will definitely come up close to 15, but not up to 15. It will be somewhere here. Then the eighth sample is 0.075, that is 7.5%. 7.5% will be between 5 and 10, and not up to 10. It will be here. Then the ninth sample will be 0.05, which is multiplied by 100 to be 5%, and the ninth one will be exactly 5%, which is somewhere here. Then the 10th one is 0.125 multiplied by 100, that will be 12%. 12.5%. So 12.5% is also again above 10. This is 10. 12.5% is somewhere above, between 10 and that's going to be here. Now you sketch the line. You come from here to here, to here, to here, to here, to here, like that, like that, like that. So you can see that all the units falls within the upper control limit and the lower control limit. So there is no one outside, there is no one above the upper control limit, and there is no one below the lower control limit. So it is saying that all the units fall within the upper. So it is saying that all the units fall within the upper and lower control limits, and hence the process is in control. So the production process is in control. So please note, it is the percentages we took from the fractions that we plotted. It is easier to plot in percentages. All you just need to do is to multiply the fractions of defective by 100, and of course the defective here are also in percentages. So at the end of the day, we have been able to successfully plot the P chart. This is called the P chart. The P chart. We have been able to, wherever the sample was taken from, it means the production process is in control. The quality is in control. It has not gone out of the standards. So the production process is within control for these 10 samples. So the production process that brought about these 10 samples is within control. So the production manager should also do more in maintaining and improving the quality. And once again, I stand to say that it is better to monitor quality at each stage of production than to do the entire production processes and wait to be monitoring quality at the end. There may be a lot of fault, but if you monitor at each stage, you'll find out that whatever defective or problem that is noticed, it will be quickly taken care of before it moves to the next stage of production. So I believe you have seen how we can apply statistical quality control in solving real life problems. I hope you were able to watch the video to the end and you have learned one or two things. So study more about the best practices of statistical quality control. Ensure that your raw materials are of high standard. Ensure that your machineries are of best quality. Your staff and employ the best skilled staff with high quality skills and experience. Always give your staff training and retraining, because if you want them to perform better, you train them on latest development. As you make sure the trend of development, you also carry your staff along. As a producer, as a manufacturer, you spend more on. That's why you see some companies can send their staff abroad for training. Some can even go as far as employing expatriates to come and teach their staff. It is part of it. It is part of improving quality. So ensure that every stage is carried out, and also ensure that the workers are also trained and latest knowledge in each area will be you expose your workers, your staff, to recent development, recent knowledge in every area of their expertise, so that they will be able to do better in their job. So God bless you. Thank you for listening to today's class. I believe you have learned something very important. I believe that you will do better if you watch the video to the end. Please subscribe to my YouTube channel, Dr. Chris Esekaibe, and click on the notification button so that each time I upload a video, you will be among those that will get the notification. Please share my videos on your social media platform, your WhatsApp, and other platforms. As you do, God will bless you richly. Enjoy the rest of the day. Bye.